Hi, this is Arthur with Achieve Educational Opportunities, and today we're going to learn how to solve homogeneous differential equations. So let's consider the following equation. dy dx equals minus 2y plus 3x divided by x. Firstly, let's put this equation into a form that's a little bit easier for us to work with. So to do so, I'm going to multiply both sides by x and by dx, which gives us x dy equals minus 2y plus 3x dx. Next, I am going to set this equation equal to 0. So we have x dy plus 2y minus 3x dx is equal to 0. In this situation, our m of xy is equal to x. So our m of tx_ty is equal to tx, which is the same thing as t to the first power times m of xy. Our n of xy is equal to minus 2y plus 3x. So our m of tx_ty is equal to 2ty minus 3tx. Which is the same thing as t to the first power times n of xy. Therefore, this first order differential equation is homogeneous of degree 1. So let's let our substitution be y equals v times x. And we'll differentiate, which gives us dy equals v dx plus x dv. And for later, we may also want to put this in terms of x. So we're going to say x equals y divided by v. And now we can begin to solve our differential equation. dy, we know is v dx plus x dv. Plus 2y minus 3x times dx. Equals 0. We're going to go ahead and distribute our x. We have vx dx plus x squared dv plus 2vx dx minus 3x dx equals 0. Now let's group all of our dx terms together. We have vx plus 2vx minus 3x and then for our dv terms we just have x squared. Okay, we can combine like terms to have 3vx minus 3x dx plus x squared dv equals 0. clean up this equation a little bit, and we'll separate our variables. We have x squared dv equals negative 3x times v minus 1 dx. From here, let's continue to separate our variables, and then we are ready to integrate. 1 over, I'm going to change this to a 1 minus v instead of v minus 1. And then over here we will now have minus 3 over x. So let's go ahead and integrate both sides of our differential equation. On the left, this integral becomes the natural log of v minus 1, or 1 minus v. We're going to change back to v minus 1. So we have natural log of v minus 1 is equal to, well, this integral is just minus 3 times the natural log of x. Plus a constant c1. I'm going to set this differential equation equal to the constant c1. So we'll have ln of v minus 1 plus 3 ln x equals c1. And from here, we can start substituting back in. So we know that our v was equal to y over x. So we could rewrite this as natural log of y to the x minus 1, or rather, natural log of y divided by x minus 1. Our second term stays the same, so we still have a plus 3 natural log of x equals some constant c1. Using our properties of logarithms, we can rewrite these. Natural log y over x minus 1 plus natural log of x cubed equals c1. Let's take both sides of this equation, and we're going to put them in the exponent of the exponential function. So we're going to say we have e to the natural log of y over x minus 1 times x cubed by properties of natural logarithms. And this equals e to the c1. This leaves us with y x squared minus x cubed equals e to the c1, with e to the c1 being some constant c. We can now rewrite this as y x squared equals x cubed plus c. So dividing through by x squared to solve for y will give us our solution. Y equals x plus c times x to the minus 2. And that is how you solve homogeneous differential equations. Thanks so much for learning with Achieve Educational Opportunities, and we'll see you on the next video.